Hello, everyone, and welcome to the Trenchless Technology webinar series. I'm Sharon Bueno, editor of Trenchless Technology magazine, and it's my pleasure to introduce today's session, Restoring Underground Pipe to Better Than New Condition, presented by Madewell Products. We have a few housekeeping items to take care of to get going. First off, we're going to take a quick poll, so please submit your answer and then click the blue Return to Presentation button. While you're doing that, let me remind you that any views or opinions presented in this webinar are solely those of the presenters and do not necessarily represent those of Benjamin Media, nor does Benjamin Media endorse any products or methods presented. Today's webinar focuses on proactive versus reactive, knowing the difference in the consequences. We'll review all methods of rehabbing pipe, introducing an emerging new method for condition assessment, equipment matters, and we'll explore past projects and accomplishments. Here's a little bit about today's presenters. From Michigan, Eric Precord is a 28-year veteran of the Michigan Department of Transportation. As a civil servant, Eric's role is to oversee all maintenance activities, including stormwater system discharge in 7 counties and 6 cities in northeast Michigan. Glenn Fowler is an engineer and owner of EnviroTrenchless, a contracting company in Warner Robins, Georgia. With 30 years experience, he has managed the trenchless repair of 250,000 lineal feet of horizontal pipes, more than 150,000 feet of vertical structures, with approximately 20,000 tons of high-strength repair mortars. Craig Closser is Vice President of Business Development for Madewell Products. With decades of experience cleaning, televising, grouting, and restoring underground assets in the collection system, Craig is instrumental in training and coaching Madewell's nationwide network of certified applicators for mainstay composite liner. Working behind the scenes is Don Rigby, Director of Marketing and Education for Madewell, and he will be driving the poll questions and directing the Q&A process at the end of this session. Now, during the presentation, you will be able to submit questions for the presenters. We encourage you to participate by typing your question into the designated panel in the left-hand portion of your screen. You can also maximize your viewing window by clicking the box with the X at the upper right of the slides. Now, with all that done, I'll turn things over to Don and get things started.
Sharon, thank you. I'm a nut about interactive learning, and this poll questions are one way we can make this presentation interactive. So here's the first one. I'll send it out right away. Current practice for repairing underground pipe. Choose one, please. Dig and replace, cured in place pipe, slip lining, cementitious lining, or all the above. I'll give you a few seconds. Results are coming in. Certainly looks like all the above. Why did I know that was going to be the best answer? Good to know. Thank you for that. And I will then we'll proceed on to our first presenter. Let's go to Glenn Fowler, please. Glenn, for some reason, I'm not hearing you either.
All right, I'm here. I've got everything unmuted now. Can you hear me?
Yes, I can. Thank you for being there.
All right. I am Glenn Fowler, owner of EnviroTrenchless. We are an underground utility contractor located in Warner Robins, Georgia. I have used trenchless technologies for about 30 years now. The first thing that I want to talk about is what makes a good candidate for cementitious lining. Well, the size makes a big difference for us. 30-inch diameter to 120-inch diameter are good diameters for cementitious lining. We generally like pipe lengths of 400 feet or less between access points. We can handle some pipes with some bends. We can handle various shapes of pipes, round, elliptical, arch, and we can handle different kinds of construction materials. We can handle corrugated metal, reinforced concrete pipes, clay, brick, ductile iron, steel. I'll start kind of with the most common, which is reinforced concrete and corrugated metal. With reinforced concrete, this probably represents only about 10% of our cementitious lining, but one of the things that we find common is that there's a lot of open joints in precast reinforced concrete pipes, and we're asked to go in and line those. There's also situations where there may be some cracking issues with the pipes, but corrugated metal is the sweet spot for us. Rusted pipe inverts, open joints, missing sections of inverts, voids in the inverts, voids around the open joints. And I'm going to kind of transition here to a quick video from our confined space drone that kind of shows the capabilities of our drone, and it shows pipes that are good candidates for cementitious lining. And I hope you find this video an interesting use of technology. So with that, I'll go ahead and get this video started.
This is video from our Helios 2 confined space drone. This drone gives us the ability to fly into confined spaces that may be impractical or too dangerous for manned entry. We find it an effective tool in quickly assessing storm pipes that have developed sinkholes or may pose a public safety concern. This quick inspection helps us develop repair strategies and to identify potential safety hazards inside the pipe should manned entry become necessary for the repairs. And as you've seen in this video, we have flown our drone in many types of pipe conditions. The Helios 2 can handle some bumping and water spray. However, hard crashes and submersion in water can cause a total loss of the unit. This is a very expensive drone, and the flights you've seen in this video require the highest level of pilot training and competency to avoid severe damage to the unit. As a disclaimer, I'm not encouraging utility owners or contractors to purchase this drone for the type of inspections you've seen in this video.
All right, I hope you found that video interesting use of new technology. The video showed pipes that were still candidates for cementitious lining. Matter of fact, all those pipes you saw in that video, we did line and repair using cementitious linings. I want to kind of transition and reiterate something I know Eric's going to talk about, and that's being proactive and about the cost of being, we should be proactive, and we want to cut down the cost of being reactive. And many of the pipes that we have rehabbed have sinkholes that are associated with the pipe. And you can see from this picture here, this is an example of a sinkhole that we can manage and take care of without digging up the street to repair it. We can even repair the pipe. But then there's the place where you're having to be reactive, and that's the picture that we have here. And this is kind of when it's too late for trenchless repairs. So just kind of want to keep making sure we emphasize the fact that we want to be proactive and not reactive. And before I finish this segment, I want to briefly touch on liner thickness. You'll see from this slide that some of the design considerations that go into the liner thickness. Most of the pipes that we line can be repaired with a 1-inch thick liner. We can do that because we have to only consider the in situ loading or the existing loading on that particular pipe. When you are installing like reinforced concrete pipe, that pipe must be designed to withstand the shipping and handling and installation stresses. That's not the case with a cast or made in place type product like cementitious lining. And with that, I'm going to toss over to Craig, who can talk more about the material and lining process.
Please do.
All right. Well, thanks everyone for coming out and taking time out for us today. My name is Eric. I'm with MDOT over here in Michigan. Just going to go over some of the best practice in trenchless technologies and how it plays out in transportation here in Michigan. So the proactive reactive portion is kind of the what we do here, and we're getting better as on the proactive part as reactive. But proactive, and I just want to share this with everybody, actions that are proactive are initiated not in reaction to a situation, but instead out of desire to make a positive change, prepare for a situation, or prevent something from happening. So that's kind of how I do, our mentality here in maintenance is with all of our jobs, whether it be any activity in maintenance, but especially in underground where it's so costly. And so we'll go over a couple of reactive. React to a situation is it's costly. We all know that. It's hard to schedule material, the process, the contractor itself that's even available. Traffic control makes it hard. Usually you got a detour in place then, and frankly inconvenience to the traveling public. Whether on the proactive side we have, proactive is more structured. We end up having a design come out of my office and we do like a large corridor project. And it's competitively bid out, so we get that contractor that you can really respect and lean on. In the long run, the proactive part plays a huge part in our asset management plan here in Michigan. So next we'll go over some tools in my toolbox. So I'm pretty fortunate in able to use quite a few different methods to repair. So first we'll just go over open cut, and open cut is not exactly a trenchless technology, but it does have its place. Usually it is ride quality becomes an issue. It's 100% reactive maintenance. There's a hole caused from a leaking tube, makes its way up to the road surface. So we do that to fill any voids too in between that tube and the road, so we get density and compaction. And then we put back the new asphalt to take care of the ride quality issue we've had. Cured in place pipe. I don't have a lot of experience using this. A couple times it requires a lot of right-of-way or area or room to work in. You see all the equipment and manpower in there. Pretty costly. One thing I didn't like about it is when we did it, it told us to any voids, to fill those voids first with a grout or cementitious material, and then in my mind it only made sense to why not just start with that type of material to do the lining itself. Also the curing process up here in Michigan, we don't always have the best weather, so the colder, wetter types, it played a part in the curing of that product as well. Here's some slip liners. And we've done some slip liners with our own crews. They're a little bit easier to do. There's a few different kinds and brands and types that snap together. Kind of get the same. You still end up with a joint in there, and I don't like that. You know, some of these other ones, the next one we're coming to, the cementitious liner, you don't have that joint in there. So, and it requires you got to fill that little void in between the host pipe and the liner itself with a grout or flowable fill. It's not always easily accessible here in northern Michigan. This is a cementitious or spin cast liner, I call it, and I've tried this method quite a few times on horizontal and vertical applications, and it's been really a good product. It's clean. It's in the end, I believe it sets up at 10,000 psi. I mean, and what I like is if it's not too thick of material, applied too thick, it comes out where we can still utilize those corrugations to slow down the velocities in the water. Here's a picture of our. This is actually a picture of our crew doing just that. They're doing a manhole and some stormwater discharge right there, the catch basin, and you can see what I like is the footprint is a lot smaller. The crew, what I think is like it's a lot less intrusive in the roadway, and of course ahead of this crew would have been a back truck to clean it out, wet it, stuff like that. But as you can see, it doesn't take up a whole lot of right of way to do that operation. This is like a before and after. So the pipe on the left, I'm sure I have quite a few that look just like that I'm not even aware of. And the bad thing is, until we do start doing these proactive corridor approaches to our highways, you don't find them until they're inspected or until that day. It's usually late night, maybe a holiday weekend, when I get a call that there's a hole in the road because it finally showed itself up on the road surface. So then on the right, you can see what I was talking about, those corrugations in there as far as helping to still slow the velocity down. It's a big factor with us in maintenance because of the erosion issues. This is a from top to bottom. So it shows. So not only do we use this product, the cementitious material, the ML72 is the one we've been using, and we use it right from the top down. So that shows our catch basin, a before and after of the catch basin. And with that material setting up at 10,000 psi, you can see all those old bricks. Once those get locked in place with that spin cast material, it really is rock solid and like dealing with brand new catch basin. And we treat that from the catch basin all the way out to the discharge end. So I believe we're going to skip right past Glenn. Already did his part and go right to Craig to take us through his next portion. Thanks.
Thanks, Eric. Craig Closser here with Madewell Products Corporation. I'm going to get into just some projects that we've ran into with our contractors that we've done in the past. And starting off here, we've got one here in Lafayette, Indiana. It's with the Pearl River project. This pipe here is 107 inches wide by 87 inches tall. The crew had to do this live with the flow in it. And they were just doing the sides. Basically, they lined everything except the bottom. The bottom had it was a limestone bottom. So they just wanted to make sure all the brick was covered. And then the block, as you see. So what they did was it required 2 inches thick. And what they did is went in and put this wire mesh in, which is probably just one of the more challenging parts. Not hard, but just getting everything on. You can see the C-channel brackets that was lagged in on the top middle picture here, and then the wire mesh that they put in. And what they would do is once that wire mesh was put up, they would basically shotcrete their mortar into that wire mesh, and it would hold about 1 inch behind the wire mesh, and then they would build it out another inch on top of the wire mesh. And right here you can see the finished product of that pipe. Again, they didn't do the bottom, whatever was the debris, the leftovers from them doing the shotcrete, that was fine for the bottom. They basically, as they walked out, they smoothed all the ripples of the mortar out in the bottom. But again, that was 2 inches thick there, and that extended that pipe for another 40 years. Got another project here where, as you can see, there's 3 culverts going under this road, not very deep at all, but just to have that road closed down for the time that would take to dig it up and replace them. The pipe was in good shape, but it was just the bottom in there. So they did the bottom and up to the spring line. As you can see, they took the corrugation out of the bottom, so there's no ripples. It was smooth. Took about 4 inches to get. The corrugation in there was so high that it took about 4 inches for them to make it smooth. So this being a creek, they just wanted the water to flow through there. They wouldn't worry about any kind of deterioration or washouts of any kind on each side of it. The white milky substance you see there in the middle, that's just like a concrete sealer that they sprayed on. Once it got hard enough to where they could walk in it, they just sprayed the concrete sealer on there. The reason they did that is just because these were open-ended pipes, a lot of air moving through there. Even though we're using the ML72 HP, again, just a lot of air moving through there, so they was just taking precautions on any kind of cracking or drying out too fast. Trust the process step by step. One is to determine the required thickness of ML72, and then determine the flow of the pump and the winch, which basically you're going to put the bucket up to your pump, determine how quick your pump is pumping, and then that'll determine the speed of your winch pulling. Set up any kind of traffic control that's needed, any kind of bypass pumping if that's needed. Cleaning the pipe. Once you clean the pipe and get all the loose material out, you're still going to have the rust and whatever the original hose pipe is holding, but you need to get out all the loose debris in there. Fill any voids or leaks, this pipe here, like that, with that hanging down, you're just going to cut that off and fill the void. So, and then any leaks that's in there. Check the pipe for alignment. Again, just like that last picture showed you that piece hanging down, you're going to want to cut that off and seal that up so you don't have that pipe or debris hanging down. Sometimes they can jack up a section of the pipe if it has a dent in it or something like that. And then spin casting for even distribution of mortar. Starts with the pump, the winch. The key is not to stop once you get going. Apply as much as possible in the first pass. Once the desired thickness is met, then you can go through there, give it a couple hours, and if you can't block the head of the pipe off, you can always spray a concrete sealer on there to keep from drying out, and then that is it. I believe from here we will move on to Don, maybe.
Yeah, I just want to say thanks for your patience on our technical difficulties. I think we get those behind us now. Here's what we did here in the first half of this presentation. We now know MDOT has every tool in the toolbox available to them, and specifically when they and why they choose cementitious lining for both pipe and culverts. We learned what size and type pipe is ideal for cementitious lining, and we witnessed a brilliant video featuring a confined space drone. There's been a lot of questions on that coming across the transit. And if there's any other questions that come to mind, please submit those now, if you would, please, for later on. But beyond a couple of project profiles, we did gain a step-by-step process for spin casting ML72 HP. And now what I'd like to do is present our second poll question, because I love these questions. So this question is about factors that affect your choice of any pipe rehab method. Is it cost? Is it longevity? Soil, groundwater conditions? Engineering spec? Or all of the above? I'll give you a couple minutes. I think I feel the answer coming. Already coming. And I'll go ahead and click. Most of it's all the above once again. I'm delighted that we keep the show moving very quickly, and I'll move back to, I believe, Glenn.
Yes. All right. I want to kind of change a little bit and and talk a little bit about cost. And I want to also talk about the cost of different alternative rehab options. One of the questions that I get asked a lot by engineers or even owners when they're trying to put budgets together or maybe an estimate for a project, and they want to know how can I come up with a ballpark, for planning purposes. And this is a formula that I came up with. It works pretty well here in the Southeast. You may need to adjust it in your area, but it represents the pricing here in the Southeast pretty well. And here's the example. You see it on the screen there. A 1/2 to 1 inch liner thickness will typically cost $5 to $7 per inch of diameter per linear foot. And just to kind of simplify that a little bit, basically you take the diameter, this is a 48-inch diameter pipe, you multiply that 48 times 5, which would equal $240, and then 7 times 48 would equal $336. So that would kind of give you a linear foot range of what cementitious lining would cost, and this would include like modest flow diversion, modest cleaning and prep type requirements, and modest traffic control. And of course, quantity will impact the price a lot. If you only have a 30-inch pipe that's 30 feet long and you don't have a local contractor that's available in that area to do it, then it's going to obviously cost a lot more than that ballpark estimate that I gave you there. Next, I kind of want to transition to some of the alternative repair methods and kind of go in order of cost here, starting with the most expensive object or process, and that would be alternative number 1. And that is the most expensive thing is to do nothing, or procrastination. This is one of the things that Eric and I both have talked about. This is when you're having to be reactive instead of proactive, it becomes really expensive to maintain your assets. The next would be, the second alternative would be dig and replace. This is typically the most expensive repair if the pipe is located under pavement or near utilities. If you're working in a shallow easement, then digging may be a better option for that. The next would be pipe bursting, alternative number 3 there. It would be the next most expensive, and this is less common in stormwater. I have seen it used before, but it's less common. It may be a good option if you need to increase pipe size by just a little bit. It's expensive. Some of the factors that can make it impractical for stormwater type applications. Then number 4 is CIPP, cured in place pipelining, and CIPP is a good fix, especially for smaller diameter pipes. However, as the CIPP gets more expensive as the diameter increases. As the existing pipe diameter increases, the bag for the CIPP gets thicker and heavier, and as Eric was talking about, it gets to where it requires a lot of equipment to move it around, and requires a large footprint. And he also addressed that it does not address the voids in the invert. And just to kind of go along with that, when the equipment that we use to apply the liner, we can use to pump grouts and fill voids and do that same thing with the same equipment. So we're not having to do something different here. Then alternative number 5 there is slip lining. That's usually the next. And this is, not rigid. These can be flipped around a little bit, but this is typically what I've seen after doing most of these processes myself. Slip lining can be a good fix in certain situations. It can fill voids when you're filling the annular space. Slip lining can handle some, it can handle a little bit of a bend, but not much, and they can't really handle a badly misaligned pipe joint. And it could cost a reduction of flow capacity, and you still have to do a little bit of digging sometimes with that type process. And then, of course, the last would be cementitious lining, and that is often the most economical that we find, and it typically requires a much smaller work area or footprint. And I kind of want to jump into a profile of a project we did in Warner Robins, Georgia. This is a 60-inch corrugated metal pipe, and from the picture there, you can see an open joint there. This was under a busy 4-lane city street that had a lot of school bus traffic. Public Works had actually inspected this pipe and saw that the invert was rusted, and they could see an open joint by just looking down the pipe. They called me and asked me to quote a cementitious lining for the pipe, and when I inspected the pipe, I walked down and took a flashlight and looked at the joint, and I could see the underside of the street from. I could actually see pavement when I would shine my flashlight up, and so the void was about the size of a Toyota Camry that was above this pipe, and you can see in the next picture here some other things going on. what actually led to this. You can see the picture of the open joint, and you can also see a clay sanitary sewer pipe that was laid through the bottom of the storm pipe. And I know there's nobody here that's ever had any of that type situations like that happen before, but the clay sanitary sewer pipe was causing the water to back up and stand in the pipe, leading to the invert corroding, and that in turn led to an open joint. I notified Public Works and told them about the void and the urgency of the situation, and they immediately closed the section of street where the void was located, and they asked us to make this repair a priority, and we were able to do that. And we actually were able to remove that clay pipe in the bottom. We found that it was actually an abandoned pipe, so we could remove it pretty easily. And we were able to take care of the void from the top of the street. And then we were able to install a 1-inch thick cementitious lining. And this is the same pipe, looking at that same general spot. And this was done a few years ago, but this repair was like a $52,000 repair, just to kind of give you a price comparison there. And with that, I'm going to toss over to Eric, let him talk about what's important to him as someone who deals with these kind of pipe repairs.
All right. Thanks, Glenn. Appreciate it. Yeah, we're going to switch gears and go over as an owner of the asset and what does MDOT expects out of the contractors, and we'll go over a little bit on permitting as well. So first, it is high priority always is safety, no matter what we're doing, what activity. So safety in PPE is required by all of our contractors, and that is reactive, proactive, whoever gets hired. If that's the first hurdle they got to jump, is they have to wear their PPE. Second is equipment. Proper lighting on their equipment, conspicuity tape, stuff like that, good working condition. Safety and practice procedures, we try to always get a knowledgeable, competent contractor. I mean, that is where it all starts, and that is going to be the where it lives, if that project is a good quality project or not. And last is a good reputation of our contractor that we hire. And when we do it proactively, like I said, we are able to competitively bid that out, and we end up with a contractor who usually will pull off our state pre-qualification list, which is a list you send in paperwork, do some money. You got to provide list of your equipment. You send it to Lansing at our capital. They review it, go over, and they get your name put on the list. So it's worth it for them guys to do that for sure. Here we'll go over some. So in Michigan we have it's Environment, Great Lakes, and Energy. The acronym is EGLE. That is our environmental permitting agent here in Michigan. So what I would say is, and I do actually have a good relationship with my environmental liaison through EGLE. I would say everybody in a transportation standpoint start there, because you need a permit, do you need a plan, design, is it emergency work, is it not? That guy will tell you. He'll help you through all this. So under the Part 301 inland lakes and streams, or Part 31 water resources protection, if stream or floodplain is involved. So I did see a question pop up from Washington DOT that we're wondering about some of the stuff like that, and it does play a part in what we do. Exempt activities is the installation, repair, replacement, or maintenance of crossroad culverts on drainage courses which do not meet the definition of a stream. So just an easy way to do it in our state anyways is you can look at a map, and is where you're at on that map, is that a blue stream? Because then usually more likely there's a trout that lives in there somewhere, and then you got to go through that process. But in cross culverts, which only serve to convey stormwater runoff or equalize the water, basically it's a equalizer pipe that just equalizes maybe a swampy area from one side to the next. Here we're going to move on to, this is just something MDOT has in place through our capital in Lansing. It's established. It's called our MDOT Special Provisions List. So what this is I compare this to our pre-qualified contractor list. So this is a pre-qualified list of materials and or activities that are listed for us to go ahead and use. So there's no second guessing what you're about to do to our road isn't the right operation. This just walks you through each portion of this special provision. It goes from the description, just breaks down this work consists of repairing the interior drainage structures by cementitious coating at the location shown on the plans. So it just breaks down each area of this. The next is goes to materials. So furnishing materials in accordance with appropriate standard specs. Construction, I'll read that out. Conduct cementitious coating of drainage structures in accordance with the standard specs, except as modified herein. Repair the interior of the drainage structure as necessary. Coat the entire interior surface drainage structure with a minimum of 1 inch of pick your product that you're going to use. We've here in the last few years used the mainstay ML72 and had good luck with that product. Conduct the service preparation, material mixing, application, and curing in accordance with the manufacturer's recommendations. Curing wasn't a year ago. We did one up here, a pretty good sized pipe, and it was in November, I believe, early November. Still cured pretty fast since it's not a driving surface. We were able to put water back on it. I think that same day it cures pretty fast, but it is dependent upon the weather. Next, we'll go over payment, measurement, and payment. So it's we usually pay by the foot, pay items per foot on a horizontal pipe, say a 36 inch by 100 feet. Pretty easy to tally that up. What comes into can be an issue is when we do the vertical structures, catch basins and such. When you get in, the top might be 36 inches, and then it opens up into a 6 foot round, gigantic manhole structure, and that's usually something we tackle on an as needed basis. And next, we'll turn over to Craig to wrap it up.
All right, thanks, Eric. Okay, so we're going to move on here. One of the good things about the ML72 HP or cementitious lining, horizontal lining, is it's all monolithic. There's no joints like we talked about earlier. Once you start at the beginning or the end of the pipe and pull back, you're going to continue to pull back and just keep that going. That way there's no joints or anything. It's all monolithic. Here's a picture here. Basically, you can see it's corrugated metal pipe. It was that we lined. So whatever is there in that hose pipe, it's going to follow that. And that's exactly why you want to be able to fill in any voids or seal the leaks, anything like that. The ML72 HP, the HP stands for horizontal pipe. It's very similar to our regular ML72. We've just put some added polymer into it, which basically what that added polymer does is not only makes it extra adhesive, but it slicks up your hoses on the inside to pump further distances, and it also helps to so you don't get any cracking in it. It's a high build mortar. You know, you can pump this and spin it on at 5 inches thick at one time. The problem is your winch is not going to allow you to do that. You can only pull your winch so slow to build that mortar up. So depending on the thickness, that's where you're going to, that's how thick you're going to pull your sled through there to get the desired thickness. If it's too thick, you'll have to make this second pass. non-shrink, crack resistant, waterproof and seals, and its structural reinforcement on the host pipe. You're extending the service life of these pipes for another 40 years once you put this liner in there. So that's another good factor. A lot of people's hearing about the geopolymers. Our geopolymer is what we call the GeoSpin. Most of the time you see those for sewer pipes. Not so much, well, I guess you see them in storm too, but it's really, there's no need for the geopolymer in a storm pipe just because you don't have the corrosive environment that you would in a sewer. Even a lot of sewer pipes, you don't really need the GeoSpin just because you've got other products that you can use on these pipes. If you do have the corrosive environment, the GeoSpin is a good product to go with, the geopolymer. You get into very highly corrosive area, there's nothing better than a top coat, you know, such as our mainstay composite liner. You're going to go through and put your cementitious on the pipe, but if it's highly corrosive, you're going to want a barrier, which is our epoxy. So we go in there and spray it with epoxy, and that's your best corrosion protection. Product is important. Conveyance is critical. Equipment equals performance. So it's like having the right tool for the job. We build all of these trailers. All of our equipment parts come out of Winchester, Indiana. All of our products made in Alpharetta, Georgia. We put out about 20 of these trailers a year, or some sort of this trailer. We custom build them. They've got the mortar mixer on the back, which is the workhorse of everything. So you can put about 8 bags of mortar in there. Most people put 5 to 6 at a time. Mix it up, dump it. They start pumping it out the rotor stator here. This unit here will do about 200 feet. So you'll have to turn around on a 400-foot section, or you can use such as like a Putzmeister piston pump. We use those as well sometimes. A lot of bigger jobs, what we'll do is we've got a silo, and you can see these white super sacks up here in the right-hand corner. Instead of 65-pound bags of mortar and having a big pile of empty bags at the end, you will take these super sacks, lift them up on top of this silo here. You've got a cutter up there that'll cut those bags open. All the mortar, of course, flows down into this silo, and then as you're ready to mix, you'll take this auger, this swing arm, you'll pull it over to your mixer. You'll just hit a button, it loads the mixer, and as they're mixing, then he'll dump it, and then you're just continually doing that. That way you don't have to just keep opening up bags and then have trash all over your job site. So it makes it fairly easy to get these super sacks on those, instead of having basically 13 skids of mortar on bags, you'll have these 13 sacks delivered to you at once. So that will lead us into the next review with Don Rigby.
Craig, one of our favorite sayings is execution is everything, right? And we do everything we can to help our certified applicators execute consistently, and we give them the equipment to get that done. Conveyance is important. Look, before we move into the Q&A portion, which I think is very valuable, here's what we heard in the second half of this presentation. Cost is always a factor in choosing a rehab method. We touched on 6 different methods, and we provided high-level cost comparisons. Glenn, you did a nice job on that. It's a very tricky topic to try and address with different East Coast, West Coast, union cost factors. It's a tricky topic. We touched on safety, and with an expectation every owner has, and we said specifications is key for doing work with DOTs. And better than new means a monolithic structure with ML72HP or Madewell's geopolymer geospin. And I will be happy to move towards the Q&A portion now, which I think equally interactive and very important. And I want to address this very first question to my friend Eric. Eric, by chance, do you recommend DOTs to self-perform or to hire a contractor? What's your position on that?
No, recently with these specialty crews, equipment, materials it takes, our crews are already topped out with our workload, our staffing, and equipment issues we have. So anything specialty jobs and processes like this, I'd highly recommend contracting it out for sure.
Got it. Craig or Glenn, either one of you step up to this question if you would. For very large dimensions, what is the difference with traditional shotcreting and our spin casting?
Craig, you wanna address that, or?
Well, I'll put, usually you get to a certain diameter, and Glenn can take this a little further, but usually when you get to a certain diameter is when you start, instead of spin casting, you'll start shotcreting it. So once you get into larger pipes, basically the spin cast can only do so much, so you get the shotcrete nozzle out and start shotcreting it.
Yeah, what we do is we have a robotic shotcrete. Basically, it pulls through the same way the spinner does, but it's rotating shotcrete nozzle that just rotates, and we winch it through the same way, so we can kind of get a shotcrete type finish with it.
Thank you, gentlemen. I bet this is not a yes or no answer, but is there any environmental permits needed to install cementitious liners in culverts?
I would think, depending on the culvert, like portion of my presentation said, it was depends on the tube. Is it a stream? Is it designated as just an equalizer pipe? Is there usually get a hold of your environmental people at your respective state, and they'll walk you through that, because it's always better to be safe than sorry. So I always go the extra mile and make sure I make that phone call. But is there aquatic wildlife in there, stuff like that? That's kind of a sure thing there. But
and we got about 5 minutes left. How do these products stand up in extended periods of freezing conditions? Boy, Michigan could answer that one, but I think, Craig, you could too. Freeze-thaw issues. So the question again is, how do these products stand up in extended periods of freezing conditions?
Yeah,
so far,
go ahead, Eric.
What we found up, no problem. What we found up here in Michigan so far is so some of them, some of the structures we've treated up here have, and outside of dewatering, they're underwater, and there's a definite freeze-thaw cycle we have up here. Goes usually from December through the end of March, and we haven't had a problem yet at all. Not even like, because I inspected what we did a year ago. I got right in there, a couple catch basins, and not even a hairline crack, and I was pleasantly surprised.
Yeah, and what I've found out is where you have issues with freeze-thaw is just when mainly it's been put on too thin. Usually you're in between 1 inch and 2 inches. You get below that, I could see some possible issues.
Glenn Fowler, what is the smallest pipe the drone can be flown within?
We can fly it actually in a 24-inch pipe under good circumstances, and that would be the pipes clean, no bad offset joints. The drone that we fly has a cage built around it, and it's about 15.5 inches in diameter. So even a 24-inch pipe, we're not going to fly it without touching the walls or bouncing around just a little bit. So we can fly in a 24-inch pipe in certain situations.
Dangerous situation, though, right? There was a question about the slides available after the presentation, and the answer is yes, we'll make sure that happens. I think within 24 hours of this event, you'll have access to promise documents and all kinds of things that I think you'll find interesting. For the CIP, I've heard some environmental concerns, leaching toxicity in the environment, especially for long-term impacts. What do you know about this? This is about CIPP, of which we on this call are really not experts on CIPP, but we know it's an alternative. Is there any, so let's not focus on CIPP. Is there any toxicity issues associated with cementitious mortar or epoxy top coating?
No, there's no concern with the cementitious products. With the epoxy, which you don't see a ton of epoxy coating of pipe of these corrugated metal pipes, you start to get into them more on, like I said before, the sewers, but still you don't get into a highly corrosive pipe usually where it requires the epoxy. But if you do, yeah, the epoxy, if you know you're using chemicals to wash that out or something like that, and they have a spill, that would be the only reason you would have an environmental concern, as if, you know, the contractor or whoever was doing the job had some sort of a spill that got down in the pipe. But as far as spraying the epoxy on the pipe, no, there wouldn't be any environmental concern.
Yeah, on the contracting end of that, the only thing that I can really say to that is that you know, we are required to prevent any of our gray water from entering any stream. So we have to take best practices to make sure none of that gets away. You know, because cement can raise the pH. It would take a lot to probably damage a pond or something like that. But we still are required to make sure that no gray water gets away from our work area.
Glenn, while you're on a roll, let me hand this one to you. This might be one of our last questions. How does the thickness of the material impact the capacity of the hose pipe? I've heard a 1/4 inch thick. Is this offset by improved flow rate?
You can get away with like a 1/2 inch thick. We put on 1/2 inch thick linings in situations where there's pipes that don't have a lot of loading. They're in backyards and there's just nothing there but the soil that's on the pipe. We will go with a 1/2 inch, and at a 1/2 inch you're going to basically profile that pipe. As you go with thicker applications, you'll get some sweeping. Actually, the material, as you're pulling the machine back, it'll actually fill in some of the corrugations a little bit. It'll still do some profiling, but it'll fill in those corrugations the thicker you go. So the thicker you go, you're going to have probably, you're really not going to get a benefit. You're going to still have some corrugation at a thinner application. As you go thicker, you're losing some capacity. So it's probably going to be about a wash either way.
Craig, one last question before we begin the exit process here. Can you spin cast directly on the void inside a pipe?
Yes, you can. The thing is, you have to stop, and you know, communication is everything when you're doing these. So you have to know where to stop, when to stop. Usually, you'll have somebody in there with the pipe to allow that. But I will say it's a lot easier to have somebody in there that's going to fill that void. You know, you start getting into smaller pipe like a 24-inch or lower, it's going to be hard to get somebody in that pipe to fill them voids. But, you know, when you get into the larger pipe, yeah, you want to fill the voids before you even start spin casting because, again, once you start pulling back that horizontal sled and spinner, you want to try to continuously have it move as you're pulling back and not stop. You can stop on a joint, you can stop on a void, but whatever it's throwing, say you've got a void on the top but not on the bottom, you want to put an inch or two to fill up in that void. Well, now you're going to have a big lip at the bottom of an inch or two where there was no void. So.
Well, thank you, gentlemen, Eric, Glenn, and Craig, for this Q&A process. I want to do one last survey here, poll question. I love these poll questions. And this one's going to read, poll question number 3 is, if proactive is better than reactive, and boy, we've heard that today, what's that mean for you? Choose one. Does that mean informal visual inspection of your pipes? Does that mean CCTV where possible? Does that mean formal condition assessment or engaging an engineering firm or all of the above? Choose one. There we go. All the above wins again. How about that? I should have second guessed. I'll ask one more question then of my panel. Guys, thank you very much. Is there any closing comments, Glenn, Eric, Craig, you'd like to make before we sign off?
Yeah, even with the 30 years of experience that I have as a contractor, I still regularly find out that I have not seen it all when it comes to this industry. And so we can't really be successful unless we're continuing to learn. And I've learned things from listening to Eric and Craig, and I want to thank you guys for your input and Don for helping put this together. And I want to thank Trenchless Technology for hosting this. And I want to thank everyone that invested an hour of their time to watch, and I hope you're able to learn some things that'll make your pipe repair decisions helpful for you.
Well said, Glenn. Eric?
Sure. I just first start with thanking everyone who was able to join us. I appreciate your time. I know I kind of jumped around quite a bit of stuff in my presentations. I really didn't know where to nail down and really concentrate on. There's so many different variables in transportation, but we touched on a lot of information, a little bit on a lot of information. If anyone has any questions, please feel free to reach out to me.
Craig.
Yeah, I want to thank everybody for basically putting this together. Thank everybody for taking the hour to listen to us. Also want to let anybody know to feel free to get a hold of any of us with any questions, or you want to demo or see equipment, anything like that. We are here to help you at any time. So thanks, everybody.
We are a support organization, are we not, Craig?
We sure are.
I'll exit with a couple thoughts. There's a demo next week at Prism Fest, which is an event happened every year in Williamsburg, Virginia. If you're in the area, do a search on Prism Fest and you'll find easy access to a demo on this very same topic. And Madewell is hosting a 2-day school on this very same topic in Winchester, Indiana. It's October 12th and 13th. You'll have access to the information in the next 24 hours. By the way, there's a post survey as you exit. There's promise documents heading your way in 24 hours, as well as the balance of questions we didn't get answered live. And then I will end this thing with a whole lot of gratitude from all of us. And I'll let Sharon put the final touch on.
That does conclude this session of the Trenchless Technology webinar series. Thank you to all of our attendees for joining us today. We appreciate your patience during our technical difficulties and sticking with us for this informative webinar. I would also like to thank Eric Precord, Glenn Fowler, Greg Closser, and Don Rigby for their participation, and Madewell Products for sponsoring this session. As a reminder, today's webinar will be archived at trenchlesstechnology.com if there's something you missed or would like to refer back to. Thank you again, and we look forward to seeing you online again at a future webinar.